Hello, I'm Robert Davies with the Utah Climate Center. In this chapter of Climate Notes, we're going to begin our discussions of climate change by first defining the fundamental notion of climate. So we often think of climate as average weather. Something like June temperatures in Seattle are usually in the 70s, or October is the rainiest month in Vermont, something like that. And for many of our everyday conversations, this is perfectly fine. But as it turns out, this definition of climate is of very limited use scientifically. So we are not going to use it. No. In the realm of climate science, the definition is much broader than just average weather. Climate scientists define climate as the statistics of the environment over time. And while this definition clearly includes average weather, its scope is much greater. So let's take a look at each of these in turn. To begin, there's more to statistics than averages, and two important examples are the notions of variability and extremes. As a very simple example, imagine two houses, one with a wildly varying temperature over a day, something like this, and another with a much more constant temperature, something like this. Now clearly, both houses have about the same average temperature, but the experience of living in them would be very different. They would have different climates. And the difference in this case is the difference in temperature variability and extremes. Specifically, the first house has a much more variable temperature environment than the second, as depicted in the two shaded regions, and greater extremes. And these are additional statistics then that are clearly critical to our notion of climate. It's important because at the end of the day, our experience of these two places with the same average temperature will be very different. Likewise, our experience of our environment is determined by more than just the weather, something that happens in the atmosphere. The presence of water, oceans, rivers, streams, lakes, for example, is clearly important. The nature of the land, fertile soil versus rocky versus frozen, or the kind and nature of vegetation, all of these things and many more are clearly important aspects of how we experience our environment. It's all connected. As it turns out, there are roughly 50 or so aspects of our environment called essential climate variables that climate scientists track in order to describe and study what we call climate. These are variables that describe our atmosphere, land, and water, and the life that lives everywhere. Now, some of these variables are familiar, such as temperature or precipitation or wind, and others are less obvious, like soil chemistry, ocean acidity, leaf coverage, and many, many more. Climate, then, comprises the statistics of all of those variables over time. Which brings us to our final question, how much time? For most everyday purposes, we take our time period to be several decades, and when you hear that the normal temperature for this time of year is such and such, this normal generally represents an average over the past 30 years or so. But scientists also consider climate over different timescales as well, from perhaps only a few years to centuries to millennia, even to thousands of millennia. Finally, it's important to mention that we can talk about climate over different distance scales as well. We can speak about local climates, regional climates, and even the planetary climate. There is a climate for the month of June in Kanab, Utah during the 20th century, and there is a climate for the planet Earth for the past million years. So there we have it. Climate, the statistics of the environment over time.